Thought for the day slow निर्गुण यार ए अन्या सो प्रभ सदा समाल जिन किया तिस चीत रख नानक निभही नाल अर्थात you worthless ignorant fool dwell upon God forever. Cherish in your consciousness the one who created you. O Nanak, he alone shall go along with you. Unit 1 Solid State Lecture 2 by Amrik Singh PGT Chemistry. Crystal lattice or space lattice. A regular three-dimensional arrangement of constituent particles in space within the crystal is called a crystal lattice. Means crystal lattice is the regular arrangement of atoms in three dimensions. Now, the following are the characteristics of a crystal lattice. Each point in a lattice is called a lattice point or lattice site. Each point in crystal lattice represents one constituent particle which may be an atom, molecule or ion. Lattice points are joined by straight lines to bring out the geometry of the crystal. Unit cell. The unit cell is the smallest portion of a crystal lattice, which when repeated in different directions generate the entire lattice. A unit cell may be characterized by its dimension along the three edges, that is E, A, B, C. These edges may or may not be mutually perpendicular. Angle between the edges, that is alpha, beta and gamma. So therefore unit cell is the unit which when repeat again and again and produces complete crystal lattice. And the concept of crystal lattice and unit cell can be understood by comparing analogy with wall and brick. We know that brick are joined in a wall to form a complete wall. Brick are joining and a complete wall is formed. In the same way, unit cell add on and a complete crystal lattice is formed. Let us study this with the example of a diagram. We are just creating a cube. Now creating a small crystal lattice and points are arranging under natural powers, and the whole is the crystal lattice, and the red lines and the atoms, they represent the unit cell. Unit cell repeats over and again, you are just seeing, and a complete crystal lattice is formed by joining unit cells. These are the blinking, these are the atoms, ions or molecules of crystal unit cell. Now we are going to discuss the types of unit cell. There are of two types, primitive and non-primitive or centered unit cell. First is primitive or simple or basic unit cell. A unit cell having lattice point only at corners is called a primitive or simple or basic unit cell. Non-primitive or centered unit cells. A unit cell having lattice point not only at corner but at some other position also is called a non-primitive or basic unit cell. Now, centered unit cells are of three types: body-centered unit cell, a unit cell having lattice point not only at corners but at the center. Body center also is called a body-centered unit cell. Face-centered unit cell, a unit cell having lattice point only at not only at corners but at the center of each face also is called a face-centered unit cell. And a centered unit cell, a unit cell having lattice point not only at corners but at the center of two opposite faces is called a centered unit cell. You can summarize that all the unit cell at least have the lattice point at the corners, And let us study this, let us understand this with the help of diagram. First of all, this is a cube is constituting here, and our atoms are the corners on at 8 corners, that is the simple unit cell or primitive unit cell. Now again, unit cell is constituting here, the point at the center of body in addition to point at corners, that is body centered unit cell. Now the unit cell simple is constituting first pointer corner, one face at the center of second phase, third phase, fourth phase, fifth phase, sixth phase, and it is known as the face centered unit cell. Now first we are constituting simple unit cell, and the point at the center of two end faces, that is end face centered unit cell. Seven types of primitive unit cells and various space lattices. All the crystals do not have simple lattices. Bravius pointed out that there can be 14 different ways in which similar points can be arranged in three-dimensional space. Thus, the total number of space lattices belonging to all seven crystal systems are 14 and are called Bravius space lattices as shown in the table. The table is showing all the seven crystal systems, their edge length, respective axial angle, respective examples, and possible Bravais lattices possible. First is cubic, rhombohedral, tetrahedral, hexagonal, orthorhombic, monoclinic, triclinic. A cubic is in our syllabus in class 12. Now there is only one crystal system, that is orthorhombic, having all the four types of unit cell: simple, FCC, BCC, and centered. Is the question, important question, that name the crystal system which have all the four types of unit cells. Okay. Number of atoms in a unit cell. Before doing this, we should know the following. Contribution of an atom present at corner is 1 by 8. Contribution of an atom present at body center is 1. Contribution of an atom present as face center is 1 by 2. Contribution of an atom present at edge center is 1 by 4. Let us study this. Suppose I have this crystal lattice and I have the point in parrot color as shown in the diagram. Okay, this point can be shared by red color, blue color, and this all these two colors. Therefore in one plane it is shared by the 4 unit cell and 4 above this. Therefore this corner point will be shared by 8 unit cells, and one will have contribution 1 by 8. Similarly, the point is present at the center of body, it is its own contribution will be 1, and at the face center, face is always shared by the 2. Therefore contribution of each will be 1 by 2, and edge is shared by 4 other, and therefore contribution is 1 by 4. This can be experimentally done. You can purchase a cube from fair and do all this practically. As shown, this atom parrot color is blinking, and when 4 unit cell will come above this, and it will become at the location shown below. 4 unit cell are below and 4 unit cell are above this. Both are the parrot color at the top and parrot color in between. Okay, it's blinking parrot color, that is showing that it is the shared, this corner atom is shared by the 8 unit cells. Primate unit cell have number of atom 8 corner, contribution of each 1 by 8, that is 1 atom. Coordination number is 6 and packing efficiency is 52.4%. Body centered BCC cubic, body centered cubic, you already know that the cubic is in our syllabus only. Unit cell 8 into 1 by 8 plus 1 is at the center of body. 2 atoms are there in body centered. And the coordination number is 8 and packing efficiency is 68%. We will later on calculate the packing efficiency as well. Now, face centered unit cell. 8 into 1 by 8, 6 are the faces. Contribution of each face is 1 by 2. Therefore, total number of atoms will be 4 in face-centered unit cell. And the coordination number 12 and the packing efficiency is 74% here. Now, as usual, we have done number of concepts here. We have studied the number of concepts. Based on this, there are some NCERT exercise problems which has to be done by the student at home. All these problems is the application part of the concept which we have learned. And similarly, some other questions are there. These are all from NCERT textbook, and answer are also provided for you. Thank you. Have a nice day.